Today I am solving O-level physics May-June 21 variant 12. At question 1, a student determines the circumference of a football. Which instrument gives reading that is the circumference of the football? In this case, you can use meter rule, but you can use rule, but in this case, you will find the diameter, but this directly doesn't give the result of circumference, but if gives the circumference directly. Therefore, answer 1. Now, I'm at question 2. A coin falls from rest to the air, eventually reaches a constant speed. There is a resultant force acting on the coin due to two forces, P and Q, shown in the diagram. Identify the force P. P is the drag force or resistive force, and Q is the weight. As the coin falls, P increases and weight remains same. Therefore, this condition best described C. Force P increases, resultant force decreases. Therefore, question 2, answer C. At question 3, the diagram show the force acting on four identical solid blocks. Each arrow represents a force of 20 newton. Which blocks are in equilibrium? For condition of equilibrium, when two equal and opposite force acts on a single body, the body remains equilibrium. This condition satisfied by the situation at P and situation at R. Therefore, answer A. Student at question 4, a student lists 3 changes that affect the stopping distance of a car. Increasing braking force, to increasing friction between tires and the road, increasing the speed of the car. The condition is with change of the or changes increase the stopping distance. Stopping distance has to be increased. Therefore, if I consider increasing the speed, a car has more kinetic energy, and stopping distance in this case increases. Therefore, answer is 3 only. It is a answer D. Therefore, 4 B. Now, question 5. The diagram show a satellite orbiting a planet at steady speed. In which direction does the resultant force act on the satellite? You see, this is the satellite, and its path is shown by dotted line. In fact, it is circle, and it orbits around the planet. Therefore, consider the concept of centripetal force, and centripetal force act toward the center of the planet, and answer for 5 is A. 5 A. Now, okay, the gravitational field strength in space is smaller than on the Earth's surface. A rocket is used to launch a satellite from the Earth's surface into space. How are the mass and the weight of the satellite affected as the satellite moves away from the surface of the Earth into space? As the satellite is launched, mass is the quantity that always remains unchanged, and weight depends on acceleration due to gravity. And acceleration due to gravity is described by the equation g proportional to 1 by r square. R is the distance from the surface of the Earth to onward. Therefore, as the rocket goes upward, g decreases and weight decreases. Therefore, situation best described by the answer D. Mass is unaffected and weight decreases. Therefore, write 6D. And question 7. Air is tapped into a cylinder by piston. Piston is moved inwards so that volume of the air is volume of the air reduces. Here is the air, and volume here is 1, 2, 3, 4, and here is 1, 2. Therefore, volume reduced to half, or volume is halved here. In this case, the density equals to density mass by volume, and mass and volume is half v. Therefore, this new density rho rho v, new density is rho 1, and this can be written as 2m by v. This is 2 rho, and rho is density for initial volume is 0.0012 gram per cm cube. Therefore, density would be doubled, and answer is C. Now 7C. Now at question 9, the diagram shows a children's wooden play tower, which change to the tower makes it more stable. We know condition for the stability is the surface area of the object in contact with the ground and height of the center of mass. More the height of the center of mass, more the body unstable. And here is more stable. We have to make this play tower more stable. Therefore, lowering the center of mass is the best describe the answer. 9C. Now, here is question 10, where on the graph is the limit of proportionality for an elastic solid. Here we see this P from for load P, extension is proportional to the load. This limit is known as limit of proportionality or Hooke's limit. Therefore, answer is at P. And answer B. At question 11, a weight of 2 Newton is hung from a spring. The extension produced is 6 centimeter. The 2 Newton weight is now removed and 8 Newton weight is hung from the spring. The spring does not pass its limit of proportionality. What is the new extension of the spring? It is extension is proportional to load, and load is weight. Weight is a particular type of force. It is gravitational force. Therefore, extension equals to A W. And extension initially is 6 centimeter, A is constant, and W is 2. Therefore, value of K is 3. Now, new extension E1 equals to K is 3 and weight is 8 Newton. Therefore, 24 centimeter new extension. And at 11, answer is here. And 11B. At 12, object is placed at depth D below the surface of liquid of density rho. You know, pressure of pressure under liquid is rho G. Here S is D, therefore D rho G. G is this rho is density of the liquid. Therefore, the situation at B describe the answer. And now write 12B. At question 13, diagram shows the dimension of a box of mass M and weight W at rest on the table. What is the pressure on the table due to the box? We know pressure equals to force by area. And their force is W, since weight is gravitational force, and area in contact with the surface is y into z. Therefore, it is at answer D. Now 13, right answer B. At 14, question 14, which graph shows the relationship between the pressure and the volume of a fixed mass of gas at constant temperature? It is actually Boyle's law, and Boyle's law describes that pressure is inversely proportional to volume, where temperature is kept constant. Therefore, P equals to A by E. And if I consider this as mathematical equation like y equals to a constant, say for 1 and B, 1 by x, and graph of this is like this. Therefore, answer is at D, this graph. Now, write 14 B. At 15, question, Work done by force F on a body is calculated by multiplying F by quantity Q. What is the quantity? What is quantity Q? And you know, the quantity Q is the work done is force multiplied by distance moved in the direction of the force, and it is at A, distance traveled in the direction of the force. Therefore, number 15 question, answer A. At question 16, a girl lifts an object of mass 1 kg from floor and puts it on a sledge 2 meters above the floor. How much potential energy gained by the object? You know, potential energy is GPE equals to mgs. M is 1, G is 10, and S is 2. Therefore, 22. And it is at D. Now, 16, question 16, D. Now, a copper rod is heated one end. Which statement describe how heat transfer occurs in the copper? Heat transfer here is by the process conduction. Conduction mainly takes place by the movement of the electrons from hot end to cool end, or in case of metal, it is atomic or molecular vibration. But the first electronic movement is electronic movement took place faster, and the situation described at answer D. Energetic free electron moves from hotter end to cooler end. 17 D. Which heat transfer process do not require medium? It is at question 18. This obviously is radiation only. You know, radiation does not require medium. It took place by the vibration of electric and magnetic field, and answer 18 C, radiation only. 19, list shows 4 physical property: mass, resistance, voltage, volume. How many these properties can be used to measure temperatures? You know, resistance has a connection with temperature. In normal conductor, resistance increases with temperature. Therefore, resistance is a property, and voltage, in this case, voltage voltage is potential difference, unit of potential difference, and work done by Coulomb per Coulomb of charge. Work done and per Coulomb of charge. C. Q. Let Q equals to I T. Here is I is the current, and current has connection with temperature. Therefore, voltage is linked with temperature. And volume from ideal gas equation uh, or if I combined Boyle's law, Charles law, and pressure law, P1 P1 by T1 equals to P1 T2 by T2. Therefore, volume is also connected to temperature. Therefore, how many of these property can be used to measure the temperature? Therefore, three properties, and 19 answer C. And I'm at question 20. The diagram shows a clinical thermometer. There is mercury, there is constriction, there is bore. Bore is a thin tube across which this mercury flows when its volume increases with temperature. Therefore, sensitivity depends on area of cross section of the bore. This area, and this is linked to the diameter of the bore or radius of the bore. And at question 20, answer is diameter of the bore, D. And this is, I have to finish my class here, and all those who are at standard 9, standard 10, and going to sit for Cambridge O level exam, my request is please subscribe my channel if you think my class is beneficial for you. And here is the end. And let me write question number at question 1 to 20. This is multiple choice question, and here is the end. Khuda Hafiz.